Okay, so it's written in C++ on the Mac, so just using Xcode. And what the program basically does, it takes an input, which is the postcode, and then calls up the government's data API. The first thing, what it'll do is it'll call up passing through the postcode, and then it looks for something called the MSOA. So it's effectively, it resolves that postcode to find the MSOA. Once it has the MSOA, you can then look up the statistics for COVID. So there's actually two API requests in there, both open APIs, no authentication or anything to do with or anything like that. The data is pretty straightforward, to be honest with you. Not too much going on there, but it comes back in JSON format. So I guess there's a couple of challenges here working with C++, is first of all getting the HTTP request to work, which is, I guess, after a lot of hair pulling out, once I kind of found the right place to look, it wasn't too bad. But even then, trying to find a decent wrapper to kind of simplify it, because C++ really, they want you to really delve into the nuts and bolts of it all, which I don't necessarily need to do for this. But it's nice to know you can. And the other thing is JSON. So JSON, of course, wasn't around really when C++ was originally written. So thankfully, someone has written a nice parser library which does actually quite a good job of it. On the VB version I wrote, I couldn't really find a decent JSON parser, lots of XML parsers. So in the end, I just did a quick hack and just did a load of string manipulation and just did it manually. So principally, what you have with C++ is you've got the CPP files, which are your source files, and you have header files. And this is a bit different to most other languages. So even if you look at C# and Java, or JavaScript or any of those, normally you would include a file just like you would PHP, but you include just the one file and it has all the functions in it. So when the program actually runs for the first time, the preprocessor kicks in, evaluates everything, loads it all into memory. C++ isn't really like that. So what happens is you have a header file which effectively describes the components, all the functions, methods, properties, members of that class. And you'd either have a library file, which is effectively like sort of a half-compiled file, which then implements that. So let's say, for example, you quite often see it with DLLs or something like that. So say, for example, if you run it against Windows, you'd have DLLs, for example, dynamic link libraries, and then the header file effectively describes to the compiler where within that dynamic link library is all the functionality that it needs to access. In this case, of course, we've actually got the source code, so it's slightly different. We don't need that. So we'd actually have the CPP file, which is the implementation of what's in the header file. So just to show you what a header file would look like, if we have a quick look here, here's a reasonably simple one. So I've got a helper class that handles the COVID stats. And simply put, we've got the class declaration here. I've not inherited it from anything, it's just a simple class. We've got the constructor here, which runs every time the class initializes. I could have put a destructor in, which runs every time it comes out of memory. So a destructor just has the tilde in front of it like that. I didn't need a destructor, to be honest. Here we've got some member variables. So the member variables are effectively like properties. Quite often with C++ classes, depending, you might have little wrapper functions that allow you to get and set, so read and write to those. Not really necessary for this, so I've just kept them just working like properties. And we've got two methods on here, one which goes off and gets the data, and the other one that just validates it. Basically, it's a simple routine that checks that you've got a valid postcode. And these are all public. So in other words, they're public interfaces to the class. Anyone utilizing that class can use those methods. I've also got a couple of internal functions as well that are not designed to be used by anyone using that class, which are called getMSOA and getStats. So these are actually the functions that do the work and go and do the HTTP requests. I could have changed those to be protected. And what protected will do is it means if you inherit from that class, you've got access to those functions, but they're not public. So I can't, unless you're part of that inheritance chain, you can't use those functions. For this, private's fine, to be honest, because they're only ever going to be used internally. Right, so that's the header file. So the implementation then is on the CPP file. So effectively then we include in whatever we need at the top. We've got namespaces, which works in just the same way as they would with C#. So for example, we've included in the SDD libraries, which gives us the input and output stream and the strings and that kind of thing. We've also got a JSON library here as well. So just like we would with something like React, I can either not include it in. I mean, React's a good example. So you could either go react.useEffect, for example, or if you just include the namespace React in, then you can just call it useEffect. You don't have to fully qualify it. And C++ works in exactly the same way. So I've got that in there, which means that I can call all the methods on JSON without having to call it JSON : whatever. I can just use it without having to that namespace. Got a destructor in there, or constructor. I'm not actually using it. Other than that, we've got the methods here. So the syntax is slightly different to other languages in that we have the class name, : and the method name. But other than that, the functionality and the syntax is just like JavaScript, literally. It's no different, to be honest with you. Down here, for example, we've got the function where we get the MSOA name. We build up the URL. I've just done a simple hack and just put the postcode on the end of it. We've got then the request wrapper. And what I'm doing is here I'm passing through the URL as part of the constructor. I've got a constructor override. So I've got two versions of creating that class. This one is just simple. I just pass the URL into it and it initializes it. Call the get request and that dumps it back into a string object. Now, one thing to notice with C++ is strings are not a native data type. As far as these languages are concerned, a string is basically an array of characters with a zero terminated string at the end of it that defines the end of that string. So it's not actually a native thing. So you have a char array or array of characters. So there is a string class and also C string class, depending on which library you're using, but they're basically pre-written libraries of functions, if you like, that you would include in to work with char arrays. So there's a very standard one with C++ called the stdio string. That's what I'm using here. So it kind of allows me to, it's literally a wrapper for a character array. Literally, that's exactly what it is. You've got all the functions that you'd expect with other languages like left, right, trim, format, but they're just part of a class, if you like, which wraps the underlying character array, so it's a bit different. So anyway, we call the get request, load that into our string response, check to see if we've got a valid response, and then for the first time I'm loading up my JSON library here and parsing it, and this has got a data type in here which is equivalent to JavaScript of an any. Now actually this is a native data type that the program has actually created called auto, and what it actually is a class with a whole load of member variables, but one for each data type. So effectively it tries to look at the data type and understand what it is and store it in one of the underlying variables. There isn't actually anything like this in C++. There's no kind of variant data type because in the real world of compiling stuff down at machine code level, there isn't either. So there's lots of wrappers for that give you that functionality and pretend it exists, but it doesn't really exist. So what we're then doing is we're then taking the variables out and reading them into member variables here, which these are part of the class. And then this function here, which then takes the statistics, just calls up a different URL, passes through the MSOA, and does exactly the same thing. I've just had to put in a couple of overrides. Just the data at the moment is returning null for some postcodes. I've just had to put a couple of conditions in there just to test whether they're null and just zero them out. Other than that, we've just got a method in here which then just converts it back to an int or a decimal. So effectively, it's quite clever the way it works. You pass a new variable, it interrogates it to work out what data type it is, and then calls whichever function to convert it from that data type. Other than that, really, very much like the Python and JavaScript way that you deal with JSON. So this is a really neat little library, I have to say. It does so much of the work. The HTTP requests, similar thing, to be honest with you. It's just a little bit of a thin wrapper around a curl command. That's kind of all that does. Basically, we just call in the curl setup. One thing I wanted to show you, though, is more for the Sammys out there, is what we do here is we're passing in a string to set the curl options. Now, the curl functions don't understand string because it's not a native data type. So this function actually then exposes the underlying character array. But the thing I wanted to show you is here is the callback. So just like the way that JavaScript works, we can pass in a pointer to a function. So it's a callback function. And that's exactly what this is. So this is a static function. So in other words, it can run outside the context of a class. It doesn't have to be, the class doesn't have to be instantiated. So it's just like a sort of global function, if you like, but it's contained within that class, if that makes sense. So I've passed in the function pointer here. So effectively when just like you would with a callback function in React, when it's processing, it's using this function to effectively read the data in and just append it to the character array. Then I've got read buffer here. Now, the way this works in C is we've got an ampersand here. So what that actually does is we have the string here, and by using an ampersand, I don't pass the string into this function. I pass a memory address to the string. So effectively, you can access the string via its memory address. So it means that I don't have to copy it like I would do a normal function, because what actually happens behind the scenes when you call a function is it will create a local version, a copy, if you like, on the local stack, use that copy that then gets disposed of when the function finishes. One of the good things about C is you don't have to worry about that. You can pass through a reference to that same memory block. It means it doesn't get copied onto the stack. It's actually the same physical amount of data held in memory. So it's a lot more efficient in that respect. And you can do the same thing with even PHP. I've seen it. You can pass stuff by reference, which works exactly the same thing. So you can pass, say, for example, a variable through by reference, which means that it's not copied into the stack. The calling function then is adapting that same memory and passing it back, as opposed to adapting a copy of it. So that works quite well. And to be honest, that's it. Then we've got the main function then that just basically glues it all together. So we've got a function at the top that says print stats. And again, what we're doing is we're not passing through the actual stats class. I'm passing through a reference to it. So in other words, I'm just telling it the memory address of one that already exists in the calling function. And so what you have in C++ is C out and C in, so console out and console in. So it's basically print function, if you like. Then we've got the main functions. This is the entry point. It's every single C++ or C program has this. And effectively what we have is the array to a character pointer, so the character array, which is effectively your command line arguments. And here we have basically a counter, which is the number of arguments that you have. I'm not using any of these. So what I do then is when the program starts, I create an instance of the COVID stats class. I then loop around asking the user to get their input, using the class to then validate that input. So I check very simply, have they entered something and is it a valid size? And I then report the function out if they haven't. So in other words, I let the class do all the work for me and tell you, you must enter a string, or it's too long, or it's too short, or whatever. So if it is valid, we come down this switch here and we can then jump out of that operation and actually go in and get the statistics. If that return is true, so in other words, it managed to get all the statistics and populate itself, it then just prints it. That's it. That is pretty much it. So that's a basic C++ program. No UI to go on there or anything like that. I'll do that as a separate exercise in MFC, but that's the basics. You've got your header files, got your CPP files for different implementation. Other than that, where it gets a bit hair-raising with C++ is where you've got to link in external objects. It's not like you can just pull a reference in and it just happens. You've got to put library files in, then you've got to have your path set up to find those library files. It's a massive ball ache, I'm not going to lie. But useful exercise. It's been a long time since I've done it.